Right, grade 9s. Today we're looking at simultaneous equations. So far you've only done just equations with one unknown. What we're going to be looking at now here are equations with more than one unknown. It's a set of equations, in fact. But we're going to go deep into it and just find out what is happening. First, let's have a look. What are simultaneous equations? Now, the word itself, simultaneous, simply means when things, or refers to when things exist or occur at the same time. So, for instance, if somebody says, oh, they jumped at the same time, and they jumped simultaneously, okay, and that's what the word means. But now, when we bring it to equations, what do simultaneous equations really refer to? Well, it's those equations that are satisfied by the same values of the variables. Now, with your high school mathematics, you're going to be dealing with equations with two unknowns, where you have two equations and you have to solve and find those two unknowns as opposed to just one unknown. Now, there is a link with those equations. It's because the variables you have to solve for, they share exact same variables. So I want to give you a glimpse of what you're going to be doing later on in your grade 9 mathematics. You'll be doing straight line graphs so that you can make sense of these values we're talking about. The two straight line graphs have got equations, and those equations have a point of intersection somewhere where the graphs meet. Now, in order to find the coordinates of that point of intersection, you have to solve the two equations simultaneously. And you can see they both have an x and a y. So the point where they meet, they share the same x value and they share the same y value. And that's what solving your simultaneous equation is going to bring about. Finding that shared point on graphs. For purposes of this lesson, we're just going to be looking at only the skill on how to solve the actual equations. So let's have a look at some examples. There are two methods. There's a substitution method, there's an elimination method. But for now, we're going to be looking at the substitution method, which I'm a big fan of, because it builds a skill you're going to need when you're dealing with more complex equations in the upper grades. So let's go. First example, we're given here two equations, y is equal to 3x minus 1 and y is equal to 5. Now, I've named the equations equation 1 and equation 2 for purposes of being able to refer to a particular equation so that you know which equation I'm talking about. And these are definitely equations of straight line graphs. Now, if we're going to solve them, luckily in this particular example, we already have a case where one of the equations already indicates that y equals to 5. So as much as it's an equation, it's already giving us the variable y is equal to 5. And then we can simply go and work out our value x by simply substituting that 5 wherever there's y in equation 1. So we get something from equation 2, we substitute in equation 1. So let's go. When you substitute there, you end up with an equation with one unknown, which is exactly what you're intending to do with every method you're doing. You need to end up with an equation with one unknown, solve for that unknown. So in this case, we solve for x, and 3x is equal to 6, and divide both sides by 3, your x is equal to 2, and you're done. So for those two equations, even if you had to draw them as graphs, you'd find that where they meet, there's an x value at the point that is equal to 2, there's a y value that is equal to 5. But for now, you're only going to be asked to solve the equations, you leave them there. Only when you get to graphs later will you be asked to do other things. You're just going to solve. We're learning the skill. Okay. Let's look at another example. Example 2. In example 2, again, we've got two equations. X is equal to negative 6x plus 9. Sorry, x is equal to negative 3 and y is equal to negative 6x plus 9. Again, here we've got a case where one of the equations is already giving us a solution for one of the variables. So we go and solve for y because we've got x. So we go to the first equation, equation 1, we substitute x as negative 3, and that immediately gives us 18 plus 9, which gives us 27. Okay, very easy, as long as you got the right method. Example 3, let's just go to more complex equations. We've got y is equal to negative 2x plus 9 and y is equal to x minus 1. Now here, unlike the previous questions, we don't have an equation that already gives a solution of one of the variables. We just got two unknowns in each equation. Now this is the skill that we're going to use now. This is where the substitution method comes into the picture really even more. You've got your equation 1 and the equation 2. We're going to take the expression in equation 2 and substitute in equation 1. The expression says y equals to x minus 1. So wherever there's y in equation 1, we're going to substitute x minus 1, because already we've got something that represents the y value or the y variable there, which is x minus 1 as an expression. So we're going to take that and substitute in the other equation. Once we've done our substitution, out comes an equation with one unknown. Solve that equation. So we solve for x, and our x equals to 2. Very easy, but again, take note, we have to substitute a whole expression wherever there was y in the equation that we're using. That was equation 1. Now, you're not done, because here now we only have x. We need to go find the actual y value. So now we take that x coordinate and substitute in any one of the two equations that we had. For now, I'm going to go to equation 2. Substitute my x as 2 and my y is equal to 1. But remember, we could have gone to any equation. So let's see what would have happened if we have taken our x and substitute in equation 1. What would have happened is we still get our answer y is equal to 1. So it doesn't matter really which equation you choose. But what is important though, you want to make sure that you pick the easiest of the two equations so that you don't make an error and end up getting the wrong answer, because there's a lot of calculations that you have to do. Pick the simplest one, get your answer, and you're there. So I would have picked equation 2 in this case. Let's have a look at example 4. Example 4, we've got equations y is equal to 5x minus 3 and y is equal to 2x plus 6. Again here, we can pick an expression in one of the two equations that represent a variable. Just important to remember that it's just these types of equations that we're getting that have had y equals. You can have an equation say x equals to an expression as well with a y on it, and you can still use that as well. So it's not only y that you must substitute. So you must not worry yourself about, oh, I'm looking for the y. It could have been any variable, as long as it's the one that makes things easy to find an expression that you can use for substitution. So in this case, I've taken equation 2 and I've gone to equation 1 and fetched the expression 5x minus 3, because this represents y, and I've substituted it in equation 2. And once I've done that, solve an equation. I end up with x is equal to 3. A pretty easy calculation there. Make sure with your signs and your additive inverses. Now we need to go find y. Take our y equals to 3, x equals to 3. We substitute it in the second equation, equation 2, and that then gives us y equals to 12. Very, very easy. Okay. Let's look at more examples. Example 5 with different scenarios. Look at this one. 2x minus y is equal to negative 6. 3y plus 2x minus 2 is equal to 0. Now, not every equation will always be ready for you saying y equals or x equals. You sometimes need to manipulate the equations so that you can get the expression that you need to go substitute in the other equation. So in this case, I looked at equation 1 and I thought, oh, that would be an easy one, because I'm noticing the y there would make life easy for us without creating fractions. So we take that equation 1 and we end up with an expression that we can use for substitution in the other equation. Remember that again, you get an expression from one equation, you substitute in the other equation. So we got an expression of y is equal to 2x plus 6. We're going to substitute that expression in equation 2. And look at what happens. It was 3y, so it's 3 times 2x plus 6, and the rest of the other terms. Now solve for x. Multiply the brackets, add like terms, and solve your x. And in this case, we will easily get our x value, and x equals to negative 2. Substitute your x in one of the two equations. I've gone for equation 1, which is the easiest to deal with, and solve for y. And your y equals 2. Very easy. Okay. Let's look at the next example. Example 6. We've got an equation y over 2 is equal to x plus 5, and negative 3y is equal to negative 2x plus 1. And I deliberately picked an equation with a fraction here, so that you know that there is always a whole lot of things that can come up, whether it's fractions or anything. But if you are able to manipulate the equation, correct it accordingly, and have an expression that you can substitute in the other equation, you'll always get your answer. So in this case, I would go to equation 1, multiply everything by 2, I end up with y is equal to 2x plus 10. Now, 2x plus 10 now is my expression that I can go and substitute in equation 2. So in equation 2, wherever there's y, substitute 2x plus 10, multiply the brackets, and solve for x. Pretty easy. And you get our x as negative 31 over 4. It's very, very easy. Now take that negative 31 over 4, go and substitute in the equations that you would have picked up. Pick equation 1 again, substitute negative 31 over 4 as x, and simplify and solve for y. Very easy. Make sure with your fractions there